Hi and welcome. In today's session, we'll be discussing multi-site collaboration on the Revit platform within one company and how this fits with our data management solutions, Vault in particular. We'll first be looking at the basic concept of Revit Server, then we'll discuss how Revit Server and Vault communicate with one another, and finally, we'll take a look at a complex situation where different sites work together in a Vault environment combined with a Revit Server environment. So let's start with the basics of a Revit Server. When working together on a Revit project, this is what people used to do. They would activate worksets within Revit, make this a central file, and each user would have a local copy of that central file. They would communicate their design changes to the rest of the Revit team by initiating a synchronize to central. This will work fine within one site, but might cause problems across a wide area network because of bandwidth issues. By using Revit Server, we extend this functionality by introducing caching technology. So from a user's perspective, nothing would actually change to their existing workflow. So what happens in the background? Well, each and every site has its own local Revit server, which will communicate with the master server. This master server would typically be implemented on the site where most Revit users are located. This master server is called the host, the others are known as accelerators. So the master site would only have a host Revit server, the other secondary sites would only have accelerator Revit servers. On each site, the way data is communicated across is very similar to the traditional workshed file. When initiating a synchronize with central, the local model would be updated with all changes from the other users, then the local file would be sent to the local server. In the case of an accelerator, that server would then communicate the geometrical changes to the host server, after which the host server sends the changes to the rest of the accelerators. To reiterate, Revit Server is not a data management solution. It is a way of communicating Revit design data across a channel with limited bandwidth. If an on-premise data management solution is needed, then Autodesk Vault Professional is the right tool. So the real question is, how does Revit Server communicate with Vault? Well, when the Revit Vault integration has been installed, when initiating the synchronize to central command, we send a copy to the Revit Server environment as described earlier. After that, the file is also automatically sent to the Vault environment as the latest version of the file. So one might argue, why are there two versions? One on Revit Server and one in the Vault environment. There's different explanations to this. At the most basic level, Revit Server and Vault serve different purposes. As I mentioned before, Revit Server is nothing more than a solution to alleviate bandwidth problems. As such, the main problem is the size of the Revit files. That is why Revit Server only stores Revit files and nothing else, such as linked DWGs for instance. If we want to trace data, even across sites, this is where Vault comes in. If a file is managed by Vault, Vault will automatically communicate all related data to the other user, including linked DWGs. Vault is a tool to use when it comes to auditing and making sure everyone has a correct version of the correct file according to security settings. For the second reason why Revit Server and Vault communicate the way they do, we need to explain a basic concept of Autodesk Vault. When working on data that resides in Vault, we never work in the Vault environment itself. What we do is we check out a file, which means we immediately create a new version inside of the Vault environment, we log that file in Vault, and send it across the network to the user who's checking out. The file then gets stored in a specific directory which we call local workspace. Once the user has finished modifying his local copy, he checks the file in, which modifies the latest copy on the server, and we get a new version. If we then check out again, the process starts all over again. So how does this relate to users working with Revit Server? As stated earlier, the first thing that happens when synchronizing with Central is that all intermediate changes of all other users are downloaded to the local copy, after which all of this data gets sent to the server. Let's think this through with multiple users then. Let's assume 4 users starting with a design that only contains a grid and levels. The first user takes care of the design on something called Zone 1. The second one will design Zone 2, etc. When the first designer hits Synchronize with Central, he downloads the changes from the others. As there are none at the start, he simply uploads his design. When the second one goes through the same process, he'll first get an update of Zone 1 in his local file, after which he uploads his local file, now containing both Zones 1 and 2. As you can see, using the same process, User 3 will upload all changes to Zone 1, 2, and his own design for Zone 3. User 4 will upload everything. So the question arises, when using this in combination with Autodesk Vault, does everyone actually need to upload their design, or is one dedicated user enough? Obviously, the latter approach is the best one. So we can actually think of these 4 users all working on the same design as a sort of shared local workspace, even across sites if need be. Okay, so we've seen Vault, we've seen Revit Server. How do we actually set this up across sites? Let's look at a specific setup. Let's say we have 4 sites that we need to connect. Let's also assume differences in usage. Some sites have many Revit users, others have less or even no Revit users at all. However, all 4 sites need to communicate on the same documents, not just Revit files. We'll need to set up both Vault as well as Revit Server on these different locations. For Vault, we'll apply a similar philosophy as Revit Server. Most bandwidth will be used on the documents themselves, not the metadata attached to them. So between the sites, we'll determine one master site and the others will point to the central database for the metadata of the documents, but we'll have a local file store that replicates data from the master site. It is clear from the slide that most users are in the States, whereas most Revit users are in South Africa. Therefore, the Vault Master Server will be in the States, the Revit Host Server will be in South Africa. In Australia, however, there is no Revit user, so no point in setting up a Revit Accelerator server there. Remember, the Revit users will only communicate through Revit Server except for one user who will be pushing info into Vault. Each and every site will log on to the local Vault file store to save data. As you can see, this is a very flexible system where we can decide which user is going to upload the files to Vault. We can use someone in South Africa, exchanging through the Revit host server with the rest of the design team, but syncing with the local Vault file store, which then gets replicated to the other sites. Or we can decide to assign the US-based Revit designer to store info in Vault. He would then communicate with the rest of the design team using his local Revit Accelerator server whilst uploading data to the master Vault environment, which then gets synced with the rest of the Vault file stores. Let's show how this actually works. To do this, I'll be using a machine with 4 VMwares on it. The machine itself will function as the Vault master server installed in the US. One VMware will be the Revit Accelerator, also located in the US. Then there's a VMware in South Africa, acting as the Vault replicated file store. The third VMware, also in South Africa, will be the Revit host server. Finally, the machine itself, which is already serving as the Vault master server, will also be used as a Revit and Vault client machine in the US. The fourth VMware is the Revit and Vault client based in South Africa. I won't go into too much detail on how to set all of this up. Our main focus here is the workflow between the client machines. When I'm using the Revit client in the US, the border of the screen will be green. For the one in South Africa, I'll use a blue border. So in fact, we'll be simulating the communication process between the USA site and the South African site. The US-based designer will be called Mark, the South African user is John. Let's take a look at Mark's setup. As he wants to be informed about changes to the model from other users, he has set his view to show model updates. He's now ready to start working on the model, so he's logging into the US-based Vault server. As the Revit host server is based in South Africa, he's using a local US-based accelerator, which will in its turn communicate with the master server, which is called Revit host. John's setup is very similar. He connects to the same Vault and Revit server setup, except that he's logging into the local Vault file store, which is replicating data from the Vault master server in the US. As the Revit host server is based in South Africa, he doesn't need an accelerator. He can directly connect to that server. Now, let's take a look at the Vault environment in which both are working. We'll use Vault Explorer to look at the setup. Let's first look at John's view of the structure. The Revit file itself is stored in the A513 project. We'll also be using a DWG file later on, which will also be stored in this project. As both John and Mark are in the same environment, Mark's view of the project is identical, even across the web. This means that no matter where we are, we always have access to the latest information. Before we start working on the project, let's quickly look at the worksets we've set up. Mark will be working in the Site 1 workset, which is situated at the top left of the plan view. And John will be working on the Site 2 workset, located at the bottom right of the view. On Site 1, we have an existing layout, so Mark will be linking in the DWG as a reference. Furthermore, Mark has been set up so that whenever he syncs to the central file on Revit server, a copy of his file is stored on Vault as well. Mark is now ready to communicate his changes to the rest of the design team, so he syncs with the Revit server. This operation will also be storing his changes in Vault as the latest version of the file. Now remember, we just linked in a local DWG file. Because we've uploaded our latest design to the central repository, Vault will immediately take care of the link as well, making sure that we are always up to date without the risk of losing data. The fact that Vault takes care of all links and XREFs is a huge time saver. And again, because we are looking at the same information in a replicated environment, John will immediately see the DWG as well. But what if he sticks to Revit? Remember, when he started designing today, there was no linked DWG. Well, all he needs to do is reload the latest modifications from Revit server. As Revit server is in direct communication with Vault, the DWG will also show up on John's environment. Remember, Revit server does not handle DWGs because it serves a different purpose as explained before, but it will communicate with Vault to make for a streamlined workflow. From John's point of view, let's do a simple modification. He wants Site 2 to look similar to Site 1, so he's simply going to move 2 of the walls, after which he's committing those changes to the Revit server environment. In the US, these changes are being communicated through the accelerator. Mark can now see in his view there has been a change as 2 walls have been colored differently. He now has 2 options. He can do a reload latest to download all of the changes, which would be the logical choice. The second option is to sync with the server. This will automatically initiate the reload latest command as well. So even though Mark hasn't changed anything to the design, he's actually going to store John's changes to Vault. As we commit changes to Vault, the system traces all of this as versions of a document, keeping a perfect audit trail of what the users have been doing. Lastly, let's take a look at another powerful feature of Vault. Because all project-related information is stored in Vault, a project coordinator can also access it without the need for expensive design tools. As he simply needs to be able to review, we're going to use Vault's built-in rendition capabilities. This means that the coordinator can ask for a visualization file himself without needing to go to the designer. He simply issues the command to generate a visualization file. This is a dedicated server called the job processor, which awaits specific tasks that he can run in the background, such as generating DWF files. Because we are in a replicated environment, we have set up the job server in South Africa, but it could be set up anywhere. For the DWF, the same rules apply as for the other files contained within Vault, which means that it will also be replicated across sites. So the preview needs to be generated only once to become visible from anywhere for anyone with the necessary access rights. If replication hasn't occurred yet, Vault will inform us and we can choose to replicate immediately, which benefits everyone on that site. This concludes the overview of setting up Revit Server in a Vault replicated environment. Thank you.